Unit rates. Key thing for something to be a proportional relationship. So we talked about this some yesterday. We're going to be graphing again. We're going to keep using that unit rate. We're going to refer to it now as our slope. And we're going to use graphs, tables, and equations. So if something is proportional, it must start at what point?
0.
0, 0. When we tell an ordered pair, it's really important that you put these parentheses because this tells me this is my x coordinate and this is my y. Okay? So when you are looking at it, it has to start at 0, 0 and make a straight line. So yesterday's homework, when you were looking at that, a couple of the questions were which ones were proportional. You should have only circled one, the one that started at 0, 0 and it made a straight line. So it doesn't matter if we are looking at it. So here's our 0, 0, right? This is our y, this is our x. Most of the ones when we start for this first half of the unit, through unit, before we take the quiz, all of yours will generally be all in this first quadrant. This is considered quadrant 1, where all the x and y values are positive. Okay? So that's how we know something's proportional. So it says, using the graph below, describe the proportional relationship using unit rate. Hint, the unit rate does not have to be a whole number. You're going to get a lot of weird fractional ones today. So having your calculator might be helpful. So if we look at this one, we can't go up from 1, right? What's our first nice point that you can see as we are looking at this? Does 5 make sense? Abby, we call it what? 0.5 what? 5, 3, if we are looking at that. So if I have that 0.53, what I want to keep in mind is we wrote up on the board to find the unit rate. You are always going to take the y and divide it by the x. Now, my hint would sometimes be for some of you, if you're looking at an ordered pair and you don't remember it's always alphabetic order, x, y. This first one, when we graphed it, we went 5 to the right and up 3. Okay, so x, y. And now if we are looking at our unit rate, we are going to say that we are taking 3 what unit? 3 miles, right? That's that ordered pair. 5, 3 means 3 miles and 5 hours. Whoop. Is it hours or minutes? Okay, good. Sorry, my fault. Minutes. Okay? So 3 miles in 5 minutes. What's 3 divided by 5? What decimal? 0.6. Right? 6/10, so 0.6 miles in a minute. So when we are writing our solution for our answer for this one, you might start with that fraction 3/5, and you can even leave your answer as 3/5 of a mile, but a lot of you like changing it to the decimal. So 3/5 of a minute per mile, or I would take 0.6. Okay? I'll take it either way. Some of you just like leaving it as that fraction, but sometimes we're going to compare fractions, so decimals are better. Okay? I think sometimes decimals are better for our unit rate. So we're going to take a look at this video. It's asking us to compare. And I just want to look through what it's talking about on this page. It says when you compare equations on a graph, do they show the same relationship? In this equation, C, that was our which variable, independent or dependent? Dependent, right, is always equal to, this 4 is called our unit rate. So the unit rate, you write this right below where that 4 is, this is the unit rate. Times, and then it's always times our independent variable, okay? Now, if I look at this equation, this tells me that I'm charging $4 per pound, right? Do you agree? If I look over here, I can also see that point going up from 1 is at $4. So equation and in a graph, how they look. So it says multiple methods. You can show how to test an ordered pair and how to use the unit rate. So as we look at this video, make Sure, I have my volume plugged in for you back here.
Did you know that equations can have pictures? Here's a complicated equation, and here's a picture. You might study why this equation has this picture in high school, but for now, let's look at a simpler equation like this. What kind of picture does it have? In this lesson, you will learn to understand proportional relationships by relating their graphs and their equations. Let's review what you already know about equations for proportional relationships. Here's a proportional relationship, $8 for 2 pounds of potato salad. You already know that the unit rate can be found by dividing. In this case, it would be $4 per pound. To write an equation, you pick a variable for the independent quantity, which is the number of pounds. And you would need to multiply that variable by the unit rate, by 4. 4W would give you the cost of any number of pounds. You pick a second variable to represent the dependent variable, the cost in this case, and you set 4W in this case equal to that second variable. So the equation is that the cost is equal to 4 times the number of pounds.
So always using that unit rate is what we're going to be looking at.
There are a couple of common mistakes we need to be careful about. Suppose you're talking about 3 miles per hour, and suppose you use t and d as your variables for time and distance. Which one is the independent variable? Which one goes on the x-axis? Well, in a unit rate, the one that is the after the word per, the one that we have one of, is the independent variable. It goes on the x-axis. 3 miles per 1 hour. So time, or the number of hours, goes on the x-axis. One more thing to be on the lookout for. If you're writing the equation, which of these is correct? Be really careful that you multiply the correct quantity by 3. In this case, we want to multiply the number of hours by 3, since it's 3 miles per hour. So this is the correct equation. First, let's learn how to compare a graph and an equation to see if they're showing the same relationship. Here's an equation, c equals 4w, and here's a graph. There are a few ways to check whether they in fact show the same proportional relationship. One way, which is a bit slower, is to test specific ordered pairs. For example, here's an ordered pair on the graph, 2, 8. Plug those numbers into the equation. In this case, they do satisfy the equation. You should test a few more ordered pairs from the graph until you're satisfied that the graph and the equation represent the same ordered pairs. A different method is to use the unit rate. From the equation, we can see that the unit rate is 4 because it's the number that we're multiplying one variable by to get the other variable. Is 4 also the unit rate that we see when we look at the graph? Well, if we find 1 on the x-axis to see how much 1 pound costs, we see that it also comes out to 4. 1 pound costs $4. So both of these have the same unit rate, therefore they're the same proportional relationship. We can also talk about how to make a graph from the equation, 3 miles per hour, whose equation could be d equals 3t. T represents time and d represents distance. How can we make a graph of this proportional relationship? Well, you've already learned in the past that you can make a table of values and plot those values and connect them. But another way is to use the unit rate. From the equation we see, and from the statement 3 miles per hour, from both of those we see that the unit rate is 3 miles per hour.
We don't always have to make a table.
So we can use that to make the graph quickly. Find 3 miles and 1 hour on the graph and plot a point there. Also, since it's 3 miles for every hour, we can get additional points using the unit rate. 3 more miles would take 1 more hour. And then 3 more miles than that would take 1 more hour again. And again. That's how we can use the unit rate to construct the graph. In this lesson, you have learned to understand proportional relationships by relating graphs and...
So when we are looking at that, as you did that first part, so we're just going to be looking at those. So now as you are looking at this one, this is the one, if you didn't construct it, please do that right now. Okay? So you should have taken your points as they were doing it, and you're just going to put those points on. So make sure, where do we have to go for sure? It has to be at 1, 3, but you have to start at, and yesterday I saw a lot of you starting your graph like at 1, 3, like you started drawing your straight line from this point on. You want to make sure that I can see 6, that I can see 9, that when you make that straight line, you want to go back and make sure you are starting it from 0, 0. You have your straight edge, and then put an arrow on. And usually as far as your graph is, extend that. So like here I would have seen, oh, that it's going through at 12, and I'm going to keep that going all the way up. Okay? So now we're going to be asked to compare two things, and this is what a lot of your homework says. Which one is a better buy? Okay? So they're going to talk about this in this next video, and it's not real long, but when you look at it, can you tell if you are looking at store B, the unit rate? Can we tell by looking at 1? What is the unit rate for store B? How many dollars? 2. Going across from here, store B has a rate of $2 per pound, right? That's how we write that if that was our quiz today, right? When I look at store A, how much are you paying per pound here? What's our unit rate? Our unit rate is what? Where did we say our unit rate is always going to be? Times the what? Times the variable. So our unit rate here is how much? $2.50 per pound, right? Now, if you're shopping, do you want to spend more money or less money for the same product? Generally less. So when you look at these, they're going to be talking about, in this case, we want the lesser one. If I was going to graph store A, let's graph that. Where's 2.5? Would you please put at 1, go up to 2.5 and put a point? Which means after 2 pounds, I'd be up to how many dollars? How about 5? 250 and 250, so I'm going to see 5. And then please go up. Another one would be $7.50, right? And then I would be up to $10. So this is store B. Please, right behind where this one is, put a B, so I know that that's your store B graph. And draw now a nice straight line for store A. You were going to draw a nice straight line for store A. So as I'm looking at store A, I'm going to have it going through 0, 0, and through all of those points. Let's see if I try that again. Okay? So, as we look at this homework, they're going to tell you 2 things. Which one is a better buy? We looked at our unit rates are $2.50 and $2. We would think that the better buy is store B, if I'm looking at it, right? So please write down better buy is store B. And the reason it is store B, you're going to be asked to explain on your homework tonight for every single one. So you're going to say which one is the better buy, in this case store B, and then it's going to say explain. And here would be your explanation. Because what? Because $2 a pound is less than $2.50, right? And when I look at the 2 lines, I notice that this one is not as steep. That means it didn't cost as much. The more expensive one is going to have a steeper line. The less expensive one, the line is going to be flatter. So when I am taking a look at this, I could give 2 reasons when you're on the quiz or on a test. You could tell me $2 per pound is less than $2.50, or you could tell me
store A is steeper than store B, so more expensive, right? Please write down this reason. This reason right here, and this one could be used interchangeably. You could say store B is flatter, so less expensive. Better buy, right? That's what we're trying to find, our better buy. Okay? So there's two different ways that you can always write that when you are looking at that. Pair proportional relationships. Which train travels faster? Train A or train B? What we need to find is their unit rate. So as you look at train A, what is our unit rate going to be? Our rate, so let's put unit rate and start us off, Rowan. We're going to do what? Wait. Are we doing A or B? Okay, A. So this is my dependent, right? This is my Y. This is my X, right? 8 miles in 5 minutes means I want to find 8 miles and divide it by 5 minutes. Take that calculator out. What'd you end up with? Yep, got it. 1.6. So we're going to write that the unit rate for train A is 1.6 miles per minute. Room there, I'm going to write it down. 1.6 miles per minute. We got to find train B. Sam, if I'm looking at train B, you got a nice point that we could use? We're looking at that. 36. How much? 36. Sam, what do you got for me? 10 is 1, right? 2 is not great. Is 3 good? Yeah. 3 is good. The other one that would be pretty good would be 6, right? I don't care which one of those 2 you want to use. Sam, which one? 3. So we're going to have 3, 5, right? So to find my unit rate for train B, please write it by train B. We are taking what? 5 miles over 3 minutes. When we do that division, John, what'd you get? 1.66667, right? So we're going to say 1.6 repeating because our calculator rounds that last one. So now we're asked which one's going faster. Do we want it to be more or less if we're trying to go faster?
More.
Okay, now when I was shopping, I wanted the least expensive. That's my better buy, right? But when I'm driving, if I want to go faster, my speed has to be more. I'm looking for the bigger one. So which one is faster? Okay, how about if we graph this point right here? Would you plot that point at 5? It's not a nice one to plot. It's at 8. It's right below that. Which one is going faster? Train B. Train B is faster. Why? 1.6 repeating is more than 1.6, right? So my answer would be train B, and my reason would be because 1.6 repeating is faster than 1.6. Someone said, how much faster? Well, 0.166666666 faster, right? Because this keeps going. And if I would have graphed this, it's going to be right below, but it doesn't make sense to graph it, right? This is the steeper line. I could use that for a reason. B is steeper than A, right? It's steeper because the slope is more. It's not that much steeper, but it's a little steeper. All right, so if you would turn to your homework back on page, I think we're on 49 we start on today, page 49. And it does go from 49 over to 51. So the thing about these assignments is they kind of take along a lot of pages because all of the graphs. Okay? So questions 1, 2, 3, 4, they ask you to find the unit rate. If you need to put this on the top of your paper to how to find unit rate, that might be helpful for some of you. Unit rate is always going to be, when we are looking at that, taking the y and dividing it by the x. And this is when you look at your ordered pair, which is x comma y. Okay? The other easy way is if you can go up from 1, but most of these you can't go up from 1. You have to go back to our 3 methods from yesterday, right? This one has no scales. You're going to assume that this is 1, right? So when you take a look at number 2, that's kind of a weird one, right? Number 1, I think you're going to be okay. Number 2, you want to pick a point, a nice point. These are actually called lattice points in mathematics. So put a point there. And then is there another point that we could use? Yeah. Where would I go? How far over? Over 2 or over 3? Over 2 and then up? 3. So, yesterday we said for unit rate, this is my change in my x, right? That's my x. So when I go to find this unit rate, how far did I go over? 2 pounds. That's always on the bottom. How far did you go up? How much did our costs go up? 3. Someone said, how do you know $3? Because each of these is 1. So you went up $3 as you increase buying 2 more pounds. This isn't a unit rate. Unit rate has to always be per 1, right? So this is telling me how much for 2 pounds. I want to know how much for 1 pound. Is it hard to do using our calculator? Take $3 and divide it by 2. That's how you're getting that answer for 3 and then like in 4. Okay? If you would please look at number 5, it says write an equation. What do I mean by an equation? My equation is always going to be in the form of y equals
something else.
Unit rate times x that we are looking at, because this is my x and this is my y. This is my dependent, my y is dependent, x is independent, okay? So when I ask you to write an equation, this is what all your equations should look like. So from this point on, you will notice on the top of the next page, when we are taking a look then, it says, oh, here's an equation, right? Below is a graph and an equation. Do they have the same proportion? So you have to compare the equation to the number 6 to the graph. You're going to say, yes, these are the same, or no, they are not the same. What are you looking at? You are looking at the unit rate for each one, right? This one has a unit rate of 4, this one has 2. You got to look at the graphs to decide those, okay? And then as you take a look at the last page is where you're doing exactly like we were doing in our notes. This last page is asking you which one is a better buy, which car goes faster, which car goes faster, which store is a better buy. So keep checking your answers. Do 1 or 2 questions, check those answers in the back, make sure they're making sense, because it is likely tomorrow we may have another homework quiz as you are looking at it. So as you are working